All right. So now what we want to do is go and create like a what we want to do, or what the project is asking us to do is that we want to reconstruct BST. I The idea here is that you want to create things. I'm wondering why. Okay, I'm going to go first with the naive solution, which is just uh, we want to reconstruct BST tree, right? So the problem is that the pre-order traversability is going to be given to us, and we have to build it exactly as how that is asking us to do it. Um, and you can see that it starts with 10, and then we have 4 to 5. What I don't really understand is that why we can't really have the normal insert mode and just insert it one by one. I guess this is what we have. I should try that first, right? Oh, yeah. Why? Weird. Okay, so they want us to do it in the hard way. And how I'm going to do it in the hardware is just to have um, what you can do is if we go over here, um, what we can do is go first with the first list, and we can see that this is first the root. What we want to determine is what's the left and right part of this binary tree. In this case, it's going to be 17, right? But how do we find that out? The code we have here is that we just search what's the next larger number to 10, which is the root, and then we save that and we break the loop, and then we recursively create a program that says, hey, create that using the left part and the right part and the root, and then we create the and then we do the left and right, and when that's done we recursively do like a smaller binary trees of that, and then we bully them up in order to create like the root thing, right? And like what, right? Yeah, I think that's a good idea. In this case, it will be bullying like 17. Uh, yeah. The next larger one is should be just 19. So bullying like that, right? And you can see that if we just were to do the that's a good idea. Yeah. 19, and here you have like we do first like 10, and we want to check what's the next one, and here if we do diagram the larger, we just do left and right, and we take 4, which means that we have like we have 4, right? And we see what's the right and left, and we can see that 5 will be the next larger one. 5 doesn't have anything, so this is just going to be 5. Then we have 2 1, we use 2 here, and we check which is the larger one. In this case is none, so it just becomes 1. And then we move this up into the larger tree, and we start putting things, right? Like it will be like 4 2 5 1, and here 17 19 18, right? That will work. Yeah, let me copy this into give me more yeah, let's code it out. So yeah, let's just check first the code before we code this out. You can see we have the for loop, and then the right left tree, and then we put that all together, and this like bubbles up. And note how you have the 1 here, which means that we skip the first one, because the first one is going to be the root, right? So the first one is always going to be like, oops, the root, which is just here, right? It's just this. I don't think this updates. Yeah, this doesn't update. It's always going to be this one, and you can see the cons, which means that it's always going to be that one. what just changes is the right and left, and this is the code to update it if we need it. It always starts with the length, which means like the math one, right? It's math plus one, which means that it should be nothing. It should be null, right? Because you have it start with 0, 1, 2, 3. The way this slice works is that 1 should be included. I think 0 is the last one is excluded, because that's just practice, programming practice. Yeah, I think that's how it works. Yeah. So yeah, let's write the pseudocode. So first, we want to have the base case, and the base case is that if the length is 0, then just return it, because that means that we are in this situation, right? Here or here. Right, that might be confusing. Also, we want to create like what's the current value and what's the right value. So we just create like base conditions. Then we update the tree, and then we create for return. Oh, green timer, sorry. Let's go. Yeah, the base conditions. What are the base conditions? In this case, the base condition will be like if let me yeah, why not? No, don't catch it though. But why? I just don't catch it. I don't catch it. Yeah. Uh, all right. Sorry. The left means just this one here, and then we do like. Okay. This should be nothing, but oh, right, because it will be like null, right? So just have it like this, and we need the indents and the current one. Yeah, you actually don't need this, so let's go. And let's update the tree now. How do we update the tree? We just update the right indents. we can have like, because this is going to be changing, we are just having red, right? Yeah. Actually, yeah. I mean, it's the same, right? Hopefully. I mean, it's probably wrong. Heck it, let's see. We do that, and if the 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 current write index is like larger than the current value, we do like if this value is like AI is larger than the current node, we just update the and that should be good enough. We update the proper, and now we create for the right and left, which means, yeah, we just create like is equal to just do like one we do like right index, which is excluded. I think it's really bad design. And then like we return it, right? We return the we have a value left and right, which means that this will be like a current node, left 3, right 3. I think this will be working. Reconstruct BST, yeah. Let's see. Okay. That is true. See. Left and right 3, right? Yeah, what's going on? Let's check. So like larger equal. Yeah. uh. Oh. Then there you go. Okay, there you go. There you go. All right, that works surprisingly.